Alright, so here we are on example 1. The instructions say solve each equation. Be sure to exclude any extraneous solutions. Alright, we're given the equation square root of 6x plus 1 minus 8 equals 3. Alright, so we go through our steps to solve radical equations. Okay. Step number 1 is to isolate the radical. So if I want to isolate the radical in this equation, I have to take the minus 8 away from the square root 6x plus 1. So I have to bring the minus 8 to the other side by adding 8 to both sides. Alright, so step 1, isolate the radical. No big deal, add 8 to both sides, and we're left with root 6x plus 1 equals 11. Right, now step 2, after you've isolated the radical, you have to raise both sides to the appropriate power. Since I'm dealing with a square root, step 2 tells me to square both sides. So I'm going to take my new equation where I've isolated the square root, and I'm going to square both sides. Now, on the left side, the square and the square root cancel each other out, they're reverse operations. So you're just left with 6x plus 1. On the right side, you actually have to perform the square. 11 times 11 is 121. So now we've reached a simpler equation where we do not have a radical anymore. Okay. So now we can just solve the linear equation. Right? Step 3, solve the resulting equation. So there's my work for solving the resulting equation. Right? To solve 6x plus 1 equals 121, you subtract the 1, divide by 6, you get x equals 20. Now for our last step, we have to check. Okay, we have to make sure that this satisfies our original equation. So let's do that quickly. So here's my check. I went back to the original equation and I plugged in my proposed solution, x equals 20. So instead of 6x plus 1 under a square root, I write 6 times 20 plus 1 under the square root. I evaluate 6 times 20 is 120 plus 1 is 121. So the question is, does root 121 minus 8 equal 3? Right, that's what it says I should equal. Well, yeah, root 121 is 11. 11 minus 8 is 3. This checks out. So in fact, our solution x equals 20 is not extraneous. It is the actual solution to this equation. So for part B, we have a new equation to solve. X equals square root of x squared minus 3x plus 18. Now, on the right side of the equation, the only thing I have is a radical expression. Okay, I don't have square root of this quantity plus some number. Okay, I don't have any other numbers being added, subtracted, multiplied, or divided outside of the square root. So my first step in solving this equation, which is to isolate the radical, is already done. So I can move on to step 2, which says I have to raise both sides to the nth power. Since I'm dealing with a square root, I have to raise both sides to the second power. I have to square both sides. So let's write that. So I take my equation, which already had the radical isolated, it already had the square root isolated, and I square both sides to get rid of the square root. On the right side, the square and the square root reverse each other and leave me with whatever is underneath. So in this case, the expression underneath is x squared minus 3x plus 18. On the left side of the equation, I have x squared. So now I have to deal with this resulting equation. I have to solve this resulting equation. The trick to solving quadratic equations is to get one side to 0. So seeing that I have an x squared in my equation, I know it's quadratic, so I'm going to try to get one side to 0. So step 3. Solve the resulting equation, which means I'm going to move my x squared over to get one side to 0. So here the x squareds go away, and actually here, because we only have 1x squared minus another 1x squared, they go away as well. This leaves me with 0 on the left side of my equation equals, on the right side the x squareds are gone, but I still have negative 3x plus 18. At this point, my equation has become linear. It has x to the first power and nothing higher. To solve a linear equation, you just isolate x. Okay? So let's go ahead and move my 18 and my 3 around so that I can get my solution for x. So here's the steps to solve 0 equals negative 3x plus 18. You move the 18 over first by subtracting. Then you divide by the negative 3 to get x by itself, and you end up with x equals positive 6. Are we done? Well, not quite, right? We have to check and make sure that it works in the original solution. So step 4, check. Right, so I'm going to go back up to this original equation and plug in 6 everywhere I see x, and make sure that 6 satisfies this original equation. So here's the work for my check. I go back to the original equation and I plug in x equals 6 everywhere I see x. So I'll get 6 equals 6 squared minus 3 times 6 plus 18. I go ahead and work out these operations. 6 squared is 36. Negative 3 times 6 is negative 18 plus 18. The 18s give you 0 because one's positive, one's negative. So the equation reduces to 6 equals root 36. Is that true? Yes. The square root of 36 is positive 6, so it checks, which means x equals 6 is a valid solution to our equation. So for our third equation, part C here, we have to deal with a cube root. Right, we're given the cube root of 2x plus 5 plus 7 outside of the root is equal to 4. So the strategy is the same for all radical equations. First, you have to isolate the radical. Okay, so let's do that. In this case, the reason the cube root is not isolated is because of this plus 7. So I'm going to subtract it over to the other side. Minus 7. Minus 7. So that leaves me with the cube root of 2x plus 5 equals 4 minus 7, which is negative 3. Now you might be alarmed about this negative, but don't be. Okay, it's a cube root. Cube roots don't have issues with negatives, right? So this isn't going to be a problem. Right, so we've done step 1, we've isolated the cube root. Step 2 says we need to raise both sides to the third power. Since this is a cube root, we have to cube both sides. So let me write it out. So when we cube both sides of our equation, the cube root and the cube reverse each other, leaving us with whatever was underneath the radical. So 2x plus 5 in this case. On the right side, we have to cube negative 3. So negative 3 times negative 3 times negative 3 is going to give us negative 27 if we multiply it out. Step 3 says I have to solve the resulting equation. Well, that's actually pretty straightforward. This is a linear equation, right? It's got x to the first and nothing higher. So I'm just going to isolate my x using reverse operations. So to isolate the x in the equation 2x plus 5 equals negative 27, I subtracted 5 from both sides, then I divided by 2, which left me with x equals negative 16. So my final step should be to check. Now, in point of fact, we don't have to check this time. Okay, because we did not raise both sides to an even power, we raised both sides to an odd power, right? We cubed. When you raise both sides to an odd power, you never actually introduce extraneous solutions. But I'm going to go ahead and check this solution anyway, just for good practice and to make sure that we can do it. All right, so let me write out the work. All right, so here's my check. I took our proposed solution, x equals -16, and I plugged it into the very original equation. Right? Always go back to the very first equation. Right? When you put x equals -16 in here, you'll get the cube root of 2 times -16 plus 5 plus 7 equals 4. Okay? Now simplify. Don't start moving things around. Okay? Just simplify. You know what 2 times -16 is. It's -32. You know what -32 plus 5 is. It's -27. You know what the cube root of -27 is. It's -3. Right? Because -3 times -3 times -3 is -27. And then -3 plus 7 is 4. So it checks out. Right? So like we thought, x equals -16 is the solution.